Hi, my name is Nick Borson, and this is the second in a series of videos about learning to program using PowerShell. If you haven't already, I encourage you to watch the first video in which I just introduce the series, talk about a little bit about what it's for, and a little bit about PowerShell, which is the language we're going to use to learn to program. But in this video, we're going to be getting a little more hands-on. So if you haven't already, I would encourage you to actually go and install PowerShell, which you can do by following, by going to aka.ms PowerShell. The link is right, you can see the link right there, and I'll include the link in the description as well. And you can then follow there'll be our links there for how to install PowerShell on Windows, the Mac, or Linux. So if you're running on Windows, I would also encourage you to install the Windows Terminal program, although that is optional. This is the terminal program right here, and you can install that from the store. So if I were to go to the store and search for terminal, then you'll find Windows Terminal, and you can install it that way if you're running on Windows 10. If you're running on an older version of Windows, then you don't need to use Terminal. You can just run PowerShell by once it's installed by hitting Start and typing pwsh, and this will give you PowerShell running in a traditional console window. Okay, enough of that. So let's get started on actually working with PowerShell a little bit. So in this video, I'm going to be talking about variables and expressions. So let's start with the simplest expression I can think of, which is to simply type a number. So if I just type 2 and hit enter, then you see we just get back 2. So that's not very complicated. So this is just typing a constant value, and PowerShell will just echo that value back to us. Now let's try something like 2 plus, oops, didn't mean to go full screen, but let's try typing 2 plus 3. And now it's instead of echoing back 2 plus 3, it's actually calculated the sum of 2 and 3, and that's what we get back. So both of these are expressions. This is a very simple expression with just the number 2, a constant, and here we have an expression that consisting of a plus operator, and then which has 2 operands. The left-hand side is a number 2, and the right-hand side is the number 3. And when we evaluate that expression, we get their sum, which is of course 5. So let's try another one. Let's say 2 plus 3 times 7. Okay, so in this case, we've again evaluated this expression as just a simple mathematical arithmetic expression. One thing I'd like to point out is that the convention in math and in PowerShell in most languages is that multiplication has a higher precedence than addition. So when we calculate this, we don't say 2 plus 3, which is 5, times 7, which would be 35. Instead, we do the multiplication first. We say 3 times 7, which is 21, and then add 2, which is 23. Another way to, if we want to make that more explicit, we can say 2 plus, and then use parentheses, 3 times 7. So that's making it very clear that this whole thing is treated as a unit. We evaluate this expression first, and then this whole thing, the value, the result of this calculation, is in the right-hand side of the plus. So it's 2 plus the value of 3 times 7. Okay, so we can hit enter, and again we get 23. We can also do it the other way around. We can override the normal precedence you get by saying 2 plus 3 times 7. So this is, again, using parentheses for grouping. And now we're saying everything inside the parentheses should be treated as an expression. So in this case, we'll evaluate 2 plus 3, which gives us 5. And this whole thing becomes the left-hand side of the times operator. So we multiply 5 times 7, and that will give us 35. So that's sort of a very simple example of how more complex expressions can be built up out of simpler expressions. So the argument for times, the operands for times, for example, don't have to be just single numbers. They can be expressions, sub-expressions that themselves are made up of sub-expressions, and we can make that as complicated as we want. Excuse me. Okay, so let's try something else. Let's say n equals 5. So now that didn't output anything. So the right-hand side of this is a number, the number 5, but the number 5 wasn't written to our output. Instead, we have the equal sign here, and then this $n, and PowerShell helpfully shows that in a different color. This is a variable. So a variable begins with a $, followed by a name. It doesn't have to be a single character. It can be something longer. And the equal sign is assigning the value on the right-hand side to the variable on the left-hand side. So now we can actually just refer to the variable, and we get back its value. And we can use that variable in expressions just in any context where we could use the value of the variable, we can use just the name. So we can say 2 plus 3 times n. And now the same way as before, this expression is going to be evaluated as a unit, 3 times n, so that'll be 3 times 5, which would be 15, and then 2 plus 15 should give us 17. So there we are. We can also assign a variable again. So let's say n is 5 plus 2. So now we've seen that the right-hand side of the assignment, instead of just being a single number, it doesn't have to just be a literal value. It can be any expression. So the value of that expression, when we evaluate this whole expression, and that value then gets stored in n. So n is now 7. So it's not just like a textual replacement. It's not like n is assigned just the text 5 plus 2. We actually evaluate this expression, and the value is stored in n. So n now becomes 7. And we can say, just as we said here, 2 plus 3 times 7, we can say 2 plus 3 times n, and we should get the same result as we did by putting in the literal value 7. So variables are very useful for a lot of reasons, but one reason is that a variable, you might think, well, what's the advantage of saying n here instead of just saying 7? We know that it's 7, but in some cases you don't really know what the value of the variable is. The variable might be a name for some value that's computed at runtime, or that comes in from somewhere else that you don't control. Maybe it's a value that comes from the user, or a value that comes from a file or some other input. So the variable then is a placeholder for some unknown value that you want to do some sort of calculation with. So far we've been working with numbers, but let's try something else. I'm going to type a different command here. I will type read host, and I'm going to type -prompt name. Okay. So now this is a command or a commandlet. So read host is the name of a command, and then these are arguments to the command. And so the prompt argument is the read host command has an argument called, or a parameter called prompt, and I'm saying that the prompt should be name. And the read host command has now printed out name : on the terminal, and I can type I don't know, Bugs Bunny. Are there two? There's probably only one G in Bugs Bunny. And we can see that it's written Bugs Bunny to the output. Well, that's not very interesting, but it is something that's different than we've seen before. We actually can type a command and have PowerShell do something. But let's see what happens. What's interesting about this is this whole command is itself an expression. So I can say name equals read host prompt name. Now it's again going to prompt us for the name, and I'll type Bugs Bunny. But this time it didn't actually output anything. You can see here it outputted Bugs Bunny. Here it did not output anything. So what happened to the output? Well, the output of the command actually became the value of the expression. This whole thing is now being treated as an expression being some little bit of code that that can be evaluated and used in other expressions, or that and yields potentially can yield a value. So the value of this expression is actually the output of the read host command. So that output is now stored in name, and if we type $name, we see that name is now Bugs Bunny. So that's interesting. And this is an example then of a variable that came from the user. So if I were writing a script that included a statement like this, then at the time of writing the script, I would actually not know what name was. Name could be anything that the user typed in. So that's an example of a variable in action. Now this is, a name is not the same thing, or this name is not a number. It's something else. This is a string. This is another very common data type in programming. You may have heard of strings. A string is simply a sequence of characters. So characters being letters, like letters or numbers or any other kind of symbol. So this is a sequence of characters, and they're called strings. It's kind of a metaphor for a string of beads or something. So the beads are the individual characters. You string them together, and the object that you get is called a string. Or I guess if you want to be fancier, it could be a string of pearls or something. But this particular string of beads has what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. So it has a length of 10. And a string is a bit more complicated than a number. So if we have a number, remember n was a number. The number is pretty much just one thing. It's a simple object. It only has the value of the number. But a string is a bit more complicated. You have a length, you have the individual characters in the string. So you can do different things with a string than you can do with a number. So this is an example of how variables, or the objects that the variables refer to, can be of different types. And depending on what the type is, you can do different things with it. So for example, name.length. So the string has a property called length, and when I type that, I can see the value of the length property for this particular string. The syntax we use here is we have the object that we're referring to is the name, and then we have the dot, and then the property name is length, and the value of this whole thing, this is also an expression. The value of this whole thing is then whatever the length is of that string. So in this case, 10. And like I said, this is an expression, so I can use that in larger expressions. And anytime you have an expression, you can build up larger expressions from it. So I can say 2 plus name.length, and I should get 12. So also, the thing on the left of the dot doesn't have to be a variable. You can have objects that are, the values of expressions that are never given names. So I can say, for example, read host prompt. I'll just say name again. And this whole thing I want to treat as an expression. But I can't say just dot here because that would be confusing. It would think the dot goes with just this name part. I put the whole thing in parentheses, go to the beginning of the line. I'm going to put a parenthesis at the beginning, parenthesis at the end. And now I'm saying this whole thing is an expression. And then I'll put a dot after it, and I'll say length. Okay, what is that going to do? Well, again, we're going to evaluate. We're first going to evaluate the expression to the left of the dot. And that's going to do the same thing read host did before. It displays the prompt that we said with a colon after it, and I can type whatever name I want. I'll type Bugs Bunny again just so we are consistent. And now, after evaluating this part of the expression, then we're accessing the length property of the string that was returned by read host. So we never actually assign the string to a variable. We actually just have a string. This whole thing right here becomes a string when we evaluate it, and then we can refer to the property of that string without ever actually giving it a name. So we got the length of the name Bugs Bunny that was returned by read host is 10. So that's kind of an interesting example of how we can build up expressions out of more complex expressions out of simpler expressions. Okay, so a string has a length. What else can we do with a string? Well, we can refer to individual characters in the string. So if we say name left square bracket 0, that's the B in Bugs Bunny. If we do the same thing with a 1, that's the U, the second character in Bugs Bunny, and so on. And G. Now, one thing that may surprise you is that we start with 0 instead of with 1. So the first character, the character of position, is the character of position 0. The second character is the character of position 1. We don't refer to the B as name 1. We refer to it as name 0. This is called zero-based indexing. Some languages use 1-based indexing, but 0-based indexing actually works out to be more convenient in a lot of cases, even though it's not probably how you are used to thinking of it. So this is the subscript operator, or you might call the array operator. So the part on the left is some object that is a collection of elements, an ordered collection of elements. So a string qualifies as that because it's an ordered collection of characters, ordered sequence of characters. And then the part inside is a position in the sequence starting with 0 and counting upwards. And then the value of this whole expression is the single element of that collection, of that sequence that is at that index. So again, we have Bugs Bunny as a sequence of characters. We have our string, if you will, of beads, where B is the bead at position 0, U is the bead at position 1, and so on. So we have our string, our sequence. We want to refer to the element at position 0, and we get back the B. Now, again, this is an expression and this is an expression. So we can actually get, it doesn't have to be a constant number. I can say, for example, we had that variable we made a while ago called n, right? N was 7. Well, we can say name n. And we get the character position 7. So 0, 1, 2, 3, 4, 5, 6, 7. And we can say name. We can use a more complex expression. We can say name n minus 1. And we get the character at position 6 because n minus 1 is 6. Or we can say we know that we want to get the last character in the name. Well, how would we do that without just hard coding the number? Well, we know that the string has a property called length. So if it's a 10-character string, we wouldn't want to refer to the name to the character at index 10 because that would actually be 1 past the end. Remember, we're using zero-based indexing. So the indices of the characters are 0 through 9 in a 10-character string. Just to demonstrate, what happens if I do say name 10? Oh, it's out of bounds, it's out of range, so it doesn't give us anything. So now in some languages that would give us something more violent than just giving us nothing. But in PowerShell, it just doesn't give us anything. But we can say name 9 would be the last character in the string. But what if we don't know the length of the string? We just know we have a string and we want to get the last character. Well, we can say name.length minus 1. So now whatever length the string has, the last character is going to be at the index length minus 1. And that will give us the Y in Bunny. Okay, so those are some expressions using strings. Here's another one. What if we have, we'll just say first equals bugs. For some reason, I always want to type 2 G's in bugs. We say last equals Bunny. Is Bunny a last name or a title or something? Anyway. So then we can say first plus last. And we get Bugs Bunny. Now it didn't put a space in between. It just simply appended the bunny to the bugs without any space in between. But that tells us that strings do support the plus operator, but it means something different than with numbers. With numbers, you actually get, you're doing arithmetic. You're taking two numeric values and you're adding them together and you get their sum. But plus with strings, just simply tacks the second string onto the first string. It appends the second string or concatenates the second string at the end of the first string, and so you get Bugs Bunny. So both strings and numbers are different types. Strings and integers are different types. They support different kinds of operations, and also an operation like plus can mean a different thing for a string than it does for a number. Also, like if I say first times last. By the way, the times operator is just an asterisk in many languages because it's easy to find an asterisk on a typical computer keyboard. It's not so easy to find a multiplication sign. But what happens when we try to multiply two strings? Can't multiply two strings together. It doesn't really mean anything, so it just gives us an error. Okay, so let's try something else. So again, this is telling us that that these objects, variables refer to objects. These objects have different types, and depending on the type, you can do different things, or the same operation actually works differently sometimes depending on the type. Again, like we have a number and we try to use the array index operator. Oh, that's interesting. Why did that happen? So n was 7. What if I say n? I didn't expect that to happen. N1. So it's almost treated like an array of exactly one element. Interesting. I don't know that you'd ever want to do that, but that's what PowerShell does with that one. But it's so it's treated like as if it were an array of one element, and it doesn't have a second element, an element at position 1, so it gives us nothing. Okay, so I was explaining a bit about types. So in general, there are lots of different types. Some of the most common are numbers and strings, and we'll define other types as we go along. Okay, so let's do one more thing. So we did the read host earlier to get a name. What if we used read host to get, say, your age? So I'm going to assign it to a variable again. Age equals read host, and I'll say prompt. And by the way, you actually don't need to type -prompt because the default argument to the read host is the prompt. But if you want to be more explicit, you can do that. So I'll say age, or I'll type your age, just for fun. And I'll type, I really don't know how old Bugs Bunny is. He's a bunny. Rabbits don't live terribly long. I'll just say he's like 6 or something. Okay, so now we've assigned 6 to age, right? So age is equal to 6. Okay, that seems to have done sort of what we expect, right? Oh, by the way, I said your age just because I wanted to make it clear that this doesn't have to be the same as the variable name. You could give any variable name you want. This prompt is literally just the string you see on the screen, and then the variable name is whatever you want to make it. Okay, so we have age. So age looks like a number. Let's try something. We'll say age plus 2. Oh, wait a minute. 6 plus 2 is 62? Well, okay, that's because age is not actually a number. It looks like a number, but it's actually a string that happens to be the textual representation of a number. So we can see that if we actually ask for the type of age. So we can actually, for any variable we have or any expression we have, we can say age get type, and that returns an object that represents the type. And one of the object's properties is the name of the type. And we can see that age is actually a string, whereas n get type is an int 32. So it's an integer. I'll explain what the 32 there means in a future video, but for now, suffice it to say that n is an integer, which is just a number that can have sort of whole number, positive or negative whole number values. Okay, so because age is a string, when you add two strings together, what you get is concatenation. You don't get arithmetic addition. So if we wanted to be able to treat age as a number and do calculations with it, we actually need to convert age from a string to a number. So we can do that. I'll go ahead and repeat the command we did earlier, but instead of before the read host, I'll say int, or I could say int 32, but int is just a shorter way of saying int 32. And I'll say, put this in parentheses because I want to make it clear that this whole thing inside the parentheses is one expression. Read host, prompt, your age. Okay, so now, again, we're going to evaluate this whole expression, and read host is always going to return a string. So even if I type in a string that represents a number, it's still actually a string. It's the sequence of digits of characters representing the number. It's not the number itself. But then what happens here? I take that string and I'm casting it or converting it to an integer. And then that's the value. The value that gets stored in the age variable now is not a string that looks like a number, it's actually a number. So let's try this again. And again, I'll type 6. I'll type 12. I'll type 6. Okay, so now if I say age, again, it looks like 6, just like it did before. But this time if we say age, get type, name, now it's an int 32. And if we say age plus 2, then we get what we expect. We get an 8. So you do actually have to care about whether you're dealing with numbers or just strings that represent numbers. Those are two different things, even if they look the same when they're printed to the screen. Okay, so I'll do a couple more commands here. We did a read host, which read from the terminal. We can do a write host. Oops. Hit enter. And this is going to just simply write to the terminal. So it sort of does what you expect. It might, by the way, host, that's a weird name, right? Read host, write host. Who's this host and why are we reading and writing from this host? Well, the host is actually the program. So there's PowerShell, the language itself, the PowerShell language itself is hosted by some program. And the program, the host program, is the program that's interacting with the user. So when you want to interact with the user, you want to read something from the user, you use read host. So host is kind of a proxy for the user. It's the program that interacts with the user. So you read from the host is really reading from the user via this host program. Write host is writing to the user via the host program. There's also write output. And that looks the same as write host. It seems like it does exactly the same thing. Why do we have two different commands that do the same thing? Well, they're not actually the same in every case. So write host, again, is writing to the user. Write output is writing output. And the difference between those is that the output of when we use a command as an expression, the output of that command is the value of the expression. So if I say hi equals write output hello. By the way, I'm using the tab key to complete these. So I say write O and I hit tab. It says, oh, okay, I think that the only command I can think of that starts with write O, or the most likely one, is write output. So it can complete that for me. Anyway, I'm writing write output hello, and nothing was echoed to the screen. Well, that's because we've assigned the output to a variable. So this command, the output of this command was hello, because it's write output. So it writes to the output. And the output of the command, when you use a command as an expression, the output of that command is actually the value of the expression. And instead of writing the default behavior when we up here, when we don't do anything with it, that output is then written to the terminal and we see it, right? But if we assign the value to a variable, then we don't write it to the terminal. We just store it in the variable. If we say hi, now we get hello. So what happens with write host? Excuse me. So I'll do the same thing as above, but I'll say write hi equals write host hello. This time, the value was written to the terminal, because write host isn't writing to the output, it's writing to the host. It's writing to the program that's interacting with the user. So this is being used to show a message to the user. And now what is the value of hi? It's nothing. In fact, we can, yeah. So hi is now nothing. It doesn't have a value because write host didn't actually produce any output. So that's the difference between host and output. Output is the value of the, in fact, write output hello is really the same thing as hello with nothing. But the value of this write output commandlet is simply the whatever you're writing. And the write host doesn't have a value. It has the side effect of displaying a message to the user. So for interacting with the user, read host, write host. For producing output, you can use write output. By the way, write host is one thing that's neat about write host is because it's for displaying messages to the user, it can do things like display messages in colors. So here we have green and blue. Well, what if we want to say write hello, write host, and we want to display hello, but we want to say it, we want to make it green. So I'll say foreground color. Again, I just typed F-O-R-E and hit tab, and PowerShell knows that write host has a parameter called foreground color, and so it filled that in for us. So we'll say foreground color green. So there are certain named colors that we can use, and then I'll just say hello again, and then we get that. And this foreground color argument doesn't exist for write output because write output is not really for this interactive thing. So I say foreground, hit tab, oh, nothing. So we have hello. What if we wanted to make part of the line, we want to say hello world, say, and make just world green? Well, I could say write host, and I'll say hello. And then I can separate statements with a semicolon. I'll say write host, foreground color, green, world. Okay, so now we should see hello in whatever the default color is, kind of this white color, and then I should see world in green, right? Let's try it and see what happens. Well, we did, but unfortunately they're written on separate lines. So write host by default is always going to begin a new line. It's going to write a new line character. It's actually a character that represents a new line after each, at the end of the command. So we can, to get these up on one line, we can suppress that. We can say write host, no new line, no new line, hello, and I'll just copy and paste this command right here, Control C and Control V, and here we have, so this is exactly the same as above, but we're going to not write the new line character after that first line, and we should see hello world with just world in green. Okay, so that's kind of fun. So what we've covered today is some simple expressions, things like 1 plus 2 is an expression. This is an expression that consists of an operator with 2 operands. We've covered the fact that we can build up more complex expressions out of simpler expressions. So we can say 1 plus 2 times 3. We've covered that we can use parentheses to control how expressions are grouped. So I can say 1 plus 2 times 3, which is going to group them differently than they were otherwise. And we've covered how we can assign the value of an expression to a variable. So we can say n equals 1 plus 2, in which case, because we've done the assignment, we didn't output the value, we just stored it in the variable, and n is now 3. And we've covered then how variables can be used in any place that the value of that variable could be used. So we can say 1 plus 2 times 3. Well, that means we can say 1 plus 2 times n and get the same result. Because a variable, the name of a variable is itself an expression. So you can build up more complex expressions out of simpler expressions. the simple expression, one of those simple expressions can be a variable. We've talked about how objects and values have different types. All these types of values are integers, and but you can have values that are strings, and depending on the type, you can do different things with it. So strings have various properties like length, and the length of a string is represented as a, it can be accessed as a property. So again, we have s equals hello. We can say s dot length. Property is referred to, and I can hit tab to complete that. The property is used by, we can access the property of an object by using the dot syntax, followed by the property name, and we get back 5 because there are 5 characters in hello. We've covered the fact that some objects are represent sequences of simpler objects. So a string is a sequence of characters, and we can refer to individual elements of that sequence using the array subscript operator. And we just count up from 0 to refer to individual elements. So these are the number inside the parentheses are inside the brackets, I mean, is the index. It's called the zero-based index of the member of that sequence, of the element of that sequence. And these in turn can be expressions. So I can say s dot length minus 1 to refer to the last character in the string. So the O in hello in this case, because s dot length is the length of the string, 5. So we can use that to build a more complicated expression, s dot length minus 1, which is that length minus 1, 5 minus 1. And then that value 4 becomes the index that refers to the last character of the string, which is O. And we've talked about how there are commands that we can use, such as write host and read host. And some of these commands produce output, and the output of the command is then the value of the command when we use that as an expression. So read, we can say s equals read host name, and when we type a name, Bob, then s then has that name as a value. We've also talked about how we can the host is for reading and writing messages to and from from and to the user. Output is for producing a value that can be stored in a variable or otherwise used as in an expression. Let's see. And finally, we've talked about how we can convert a value from one type to another if it is possible. So we can take a string like s equals 10, and we can convert that to an actual number, n equals int s. And although the s and n may look the same when we print it to the terminal, they actually behave differently because they have different types. So s plus 1, because s is a string, means we're appending a 1, and we get 1, 0, 1. So we have a 2-character string, we're appending another character. Whereas n plus 1, we're taking the number 10 and adding 1, and we get 11. Okay, so there's quite a bit to unpack there. I would encourage you to play around with PowerShell yourself, try some of these different things, and in the next video we'll actually try writing our first script. So we'll create a file that contains commands, and we can sort of play them back and create a little bit more complicated things. And so I hope you have fun. Thanks. Bye.